Okay. Hi everyone. Today I will be walking you all through a small thought process about how we can innovate from a very structural point of view of curriculum design and how we probably would like to integrate multiple subjects into every class rather than just create silos of subjects while teaching our students. So I will first talk to you about what interdisciplinary curriculum design looks like, what it is. So what we want to do is we want to create learning experiences which combine preferably more than one and generally three or four disciplines into one cohesive learning experience. What that does is essentially it breaks down these silos between subjects, which oftentimes students are not able to jump over on their own. And at when they reach a high school or a bachelor's level, then they realize that they must jump over these silos and they are not well equipped in order for them to do so. So the intent over here is that this combines multiple concepts and helps students understand the relevance of the things that they're learning. I'll quickly jump into a reaction into an example to demonstrate my case. Um, this is a reaction which all of us has seen at some point or another. In class 10th, this reaction is introduced for the first time. It's an exceptionally heat-producing or exothermic reaction where iron oxide and aluminum are mixed. It gives molten iron and aluminum oxide. Um, but my question for all of you is that, do you remember reading about this reaction or not? And I will let you think about that on your own. Next thing is, I want you all to tell me if you remember learning about World War II in your up to class 9. I've kept it up to class 10. Every concept has been kept up to class 10 because of a very specific reason, wherein I'm not assuming that audiences would have studied a specific subject, but history and science are common denominators of the subjects which are taught in these grades up to class 10. And the third thing I would like to all to think about is, do you remember about the nuclear bomb and its significance in World War II? Now, uh, I am making an assumption here, but a lot of you will be able to tell me that nuclear bombs invention and usage was the primary reason of the ending of World War. And it was the attacks on Hiroshima and Nagasaki which ended the World War II's aggression by the Axis forces. But if I bring you back to this reaction and I ask you, what was the relevance of this in in the World War II? Most of you probably A would not even remember this reaction, and B, more likely, is you would not know what the relevance is because you've never been told or you've never really been interested. But everybody knows the importance of nuclear bomb, and both of these are linked to World War II. And before I deep dive into how that example translates, I want you all to just take a minute and think the benefits that we can avail from interdisciplinary approach, wherein we are encouraging students to think very critically and creatively about the entire spectrum of topics. We are asking them to connect dots by presenting them a story, right? We are asking them to problem solve from not just one perspective. We are asking them to problem solve across many subgenres of thoughts and processes. Uh, and most importantly, and this is the piece which I have seen teachers struggle the most with, is that it makes their learning relevant and very engaging for the students. Because if I know that the nuclear reaction was the thing which ended the most horrible war of 20th century, then it will stay with me. But if I tell you that thermite reaction exists, it's exothermic, you would probably forget about it. So if I am able to integrate the thermite reaction into its relevance in the world, let's say in the World War II, then it might stay with us and we might be able to apply it to things which are unique and new. So I'll just showcase the example, the case study of the thermite reaction in World War II. Yeah. So I want everyone here to pause the recording, if you may, and take a couple of minutes to think how this simple reaction or this simple scientific principle, and again, this is a small amount of rust, essentially. Fe2O3 is basically rust and dehydrated rust, but rust and some aluminum, which is just aluminum foil, in which is available in your homes, can be combined to make something which really impacted how the war was fought in 1930s and 1940s. So everybody knows about Normandy invasion. At least if you haven't known, then you would have heard about it in movies, in TV shows. Everybody knows that a lot of lives were lost, but it was crucial that this invasion was won, because if it wasn't won, then the Allied forces would not have made progress against Axis forces, and so on and so forth. So, what was the purpose of thermite? The thermite reaction was actually used to demolish the artillery pieces of the German forces at that point at Normandy. Because if you don't demolish the artillery, the scattered troops, even if you invade and capture posts, the scattered troops can come back and ward off the incoming forces later on. So it is essential to demolish the artillery pieces. So it is strategically very important to disable the enemy artillery during such an invasion, because otherwise every line which is captured keeps getting going back into the hands and keeps getting reused by enemies. So in this one tiny example, one tiny reaction, what I have done is I have taken chemistry, I have taken warfare, I have taken history, and I have taken the ingenious of soldiers at that point to be able to problem solve and come up with these solutions to defeat a force of technological force of the German and the Japanese Axis forces. I will showcase one more example of what the hypothetical use case of this reaction was. Um, if you know, Gustav Gun was one of those feats of German engineering which were not like commonly available. It was one or one of two guns available in the world. So the size of this gun was so large, just to give you an estimate, that it required about 2,000 people to just operate and move this. And it could only move on railway tracks and nowhere else. It was called the Gustav. The Gustav gun was the size of about, I think, over 1,000 tons, probably bigger. And it could shell areas which were significantly farther away than any artillery could do. The imaginary scenario was that if one commando could drop on top of this gun or drop near this gun and could climb on top of this gun, use the thermite reaction, then they could disable this 1,000-ton plus gun with just a pouch full in their pocket. Okay, so that was the hypothetical. Actually, there's no record that it actually ever happened, but this was the hypothetical scenario that we were that the Allied forces had posited at that point in time. So imagine a student learning that the biggest gun in the world, which could not be bombarded upon, could not be disabled with bombing, could not be disabled with grenades, could not be disabled with mines, but with a pouch of aluminum and rust can be taken apart. That would stick with a student, that will stay with a student, and they would not just be encouraged to look it up, but they would also be encouraged to understand more about this reaction, understand where it could be applied today, and how could they use something like that to problem solve in their day-to-day life. So the pedagogical implication are very interesting about this. And this is one small niche 15-minute conversation example, which I have just showcased to you. And you can imagine how you would be able to do this at a much, much, much larger scale with many, many disciplines coming together. I've just integrated two at this point in time. So question we want to ask is, how do we incorporate these interdisciplinary examples into our curriculum design? So first thing is to, of course, using case studies like I have just done, right? The second, probably, which is much more interesting for me, is to have cross-disciplinary projects or cross-disciplinary discussions and research. So when I say cross-disciplinary projects, you can imagine, um, say I tell you that I want to create an electric motor car, which has to operate with a battery, but it has to be cost effective. It has to have a demand in the market because I want to go and sell it. So now what I have taken is I have taken the concept of electric circuits. I've taken the concept of um, uh, electric circuits. I've taken the concept of economics. I've taken the concept of financial literacy and put them all together into a one tiny small project, which then the students have to go and perform, right? They have to optimize for cost, they have to optimize for how they're going to design, how they're going to sell, what the USP is going to be. So all of these things come together for the student to be able to create something, and as a result, be very engaged. And this is something which I have seen inside my classrooms as well, that student engagement just shoots up quite a lot upon introduction of these things, and their retention of the concept also goes up quite a lot upon introduction of these methodologies. The strategies which I recommend, which I think some of you can try to implement and get back to me if possible. There is collaborative planning among teachers from different subjects. So in this scenario, I've given an example of how chemistry and history teachers can sit together and figure out how to create lesson plans, because again, science and history are interlinked in ways which is like you cannot separate them in any way, shape, or form. So history and science go very well hand in hand. But so does computer science, so does language, so does mathematics, and so on. Project-based learning that integrates things like history, science, social studies, math, and so on and so forth. And most important, in my opinion, is use of real-world case studies to illustrate these interconnected concepts overall. Uh, yeah, the impact that you might see is understanding of relevance. This thing is largely missing from most of our classrooms today, that students don't know why they're learning what they're learning. And this has been the hill which I have been harping on for last 5 years at this point in time. Wherever I've tried to work on this concept to show students relevance of why they're learning. Of course, it will improve problem solving, and there is plenty of research which I can share upon this as well. And of course, the most important part, which we want every student, see, the second part is important, but those skills can be developed through n number of ways, right? The part one and three are not some things which can be developed in n number of ways. There are only like handful of ways in which we can develop those. So showing relevance to the students and encouraging lifelong curiosity is something which cannot be done in the absence of, in my opinion, in the absence of cross connecting across disciplines. Because if things are consistently taught in silos, students will consistently start feeling that these topics are not relevant to them. They don't know why they're learning, and as a result, they will continue not retaining these pieces. All right. I will wrap up quickly today, and please, if there are any questions, please do ask.
Yes, sir. Thanks, Mr. Jeetesh. If you can stop sharing your screen, then thank you. So you have discussed how it is different from the traditional teaching methods and its benefits and everything. So you have even discussed about what subjects can be combined and the teachers' collaboration. So, sir, how do you assess student learning in an interdisciplinary curriculum?
So assessment doesn't have to change because when I'll use an example which is um, I'll use an example which is prevalent in grade 10 as a common placeholder, because again, boards are ongoing right now, so I just want to keep that on focus. So think of three cases. Okay, think of the case. I think everybody remembers the poem about the albatross, which is the bad omen for a ship, which is the guiding principle for the ship. Everybody remembers the concept of buoyancy, which we study in class 9 and 10. And I think everybody remembers the concept of uh, direction map reading from geography. So now we have, and everybody remembers the history of naval movement, right? So now there are four concepts which I have covered here, right? One is the literature of the story of Albatross. Another is the buoyancy concept of physics. Another is a concept of historical naval movement, and another is a concept of reading, understanding geography of areas. So when I have covered those four concepts for the students, you assess them in the same way as you would assess when you were teaching them in silos. You can also assess them in a combination, but you don't have to update your assessment. You don't have to introduce some overhaul of the entire system in order to integrate this idea um, into your classrooms. So testing can be done on its own as it was. And the expectation is, because students understand the relevance across the board, they will be able to adapt and understand concepts deeper, not shallower.
Right. So, sir, how can teachers promote student autonomy in this learning?
The student autonomy, I think, can come very easily when you are taking the example of projects and taking the idea of projects into this format. Because while doing projects, the best thing that a teacher can do for a student is leave them alone and only guide them when a student calls upon that, hey, I'm stuck and help me. Yes, it does reduce the rate of course completion, if you may. But what ends up happening is that, because you're giving, let's say, 2 hours to the students to work on the project, let's say once in a week, in those 2 hours over the course of 1 month, the student will finish 2 chapters worth of work. And projects, I'm trying to justify a lot of things, so I'll just narrow back down to the question you had asked. The projects can be the piece which helps the student gain a lot of autonomy in their classrooms due using these projects, using this method. But even in the absence of projects, or even in the absence of the teacher's ability or the student's ability to do projects in the classroom, what can be done is that teacher can just structure a conversation and have the student role play as different um, important individuals of that segment. So, for example, say uh, say you are the teacher guiding the conversation about history of World War II. I'm just taking to the example which I've taken. And you want people to be taking the role of Winston Churchill. You want the people to be taking the role of, say, um, Oppenheimer, and you want the people to be taking the role of these key players during that time frame who want to uh, who want to impact change, or you want to take the role of Alan Turing, who broke the Enigma machine at that point. So you want people to take these key roles and understand from their perspective, research on their life, and come back and have conversations, showcase what they did, talk about their contributions, and so on and so forth. So those, in the absence of hands-on projects, even in the absence of those, students can take a lot of student can have a lot of direct involvement into what goes on inside the classroom.
It improves the critical thinking too. Right.
Yes, yes.
So, sir, you mentioned about teachers from different departments collaborating with each other. What,
Mhm.
in your view, what role can community partnerships play in interdisciplinary learning?
Um, so I'll use an example for that, if that's okay with you.
Yeah, yeah.
So I was part of this, I was visiting this school on a regular basis, wherein students were generally from a relatively low income background. And what ended up happening is that they would invite the local car mechanic on bicycle. I think it was bicycle. Yeah, I think local bicycle mechanic to come inside the school and teach the students on how to work on bicycles, what to look for, how to fix puncture, how to fix a broken chain, how to tighten the handles, how to fix spokes of a tire, etc., so on and so forth. Right. So the concept is that uh, you can bring in members of community. And one thing which I have tried doing is I have brought in software developers from my circles into my classrooms, and they have just talked about what they are doing.
Mm.
And what they would do is they would spend an entire day with the students if possible. So generally tends to be a Saturday, wherein and students like come in voluntarily, wherein the students will think about ideas which can be done and how can they be done, and then they would sit down, brainstorm, create algorithms, processes, and so on. So that's how community can be very comfortably brought into these equations. And again, if you bring in an actual industry professional, so let's say somebody's parent is a say an ESG consultant, right? So just a broad spectrum job I'll take, wherein they are helping the company meet ESG goals, right? And you bring them on board, and the students brainstorm ideas as to what the company can do, what the consultant can um, think of doing, and contribute processes, create voluntary engagements with the students to go in and help on these processes, create voluntary engagements with the um, workers of the company, employees of the company to go in and do these voluntary engagements. So again, when you bring in real life professionals, it doesn't matter what level they are or what they're doing. It's just about giving the students some form of autonomy of what they are doing inside the classroom. And if we are able to manage that, if we are able to actively make sure that they are engaged, then students will, I'm from my experience, retain much better, be more engaged, and find the content a lot more relevant.
Right. So, sir, I have received one question now. It's again regarding the assessment part. You have already explained that, in detail. But since I have received it, I would like to ask you the same. What are the challenges of assessing interdisciplinary learning?
Um, See, it obviously doesn't fit uh, the exact mold of board examination which currently exists, and it will not fit the standardized test mold either very comfortably, right? Because there isn't a lot of scope for practice when you're um, learning through project or learning through um, discussion and such. But what ends up happening is that if we are able to do this well, the outcome of this is there is sufficient interest inside the student's mind. And this, I'm talking majority of students, not all the students, but interest in majority of the students' mind, that they would want to go in and learn more. And that's what we want. That's what I always prefer as an outcome for the students. That you go in and you learn on your own, because that way you will learn what you want to and retain much better. And yes, assessments do become difficult, but again, they don't have to be, it doesn't have to be an opposing force that you did this, so you have to assess in this way, which doesn't jive with my board exam. So you can be like, we did this, now let's practice the NCRT questions, right? We understand the concept now, let's practice the NCRT questions, and then we will do our assessments just the same. We don't have to change everything in one go. We can just impact one small change first and then see, right? You don't have to overhaul again the entire system in one go.
So, sir, in connection to the same, how can this interdisciplinary curricula be scaled up?
So in that regard, like the NEP was a very decent step by the government. Its application into the day-to-day school is yet to be fully realized, let's say. But I think one of the interesting things that schools end up doing when they hear things like hands-on learning and projects is that they bring in kits, or they will bring in Lego sets. But those are not the things you want to do there. Those are very defined, rule driven solutions. What you want to do is you want to give students a little more freedom on how they would solve X problem. Um, how to work on this on scale? It's very difficult because, again, these are individualized classrooms with individualized learning requirements, and these problems have to be on a local level. However, there are some companies and there are some individuals who are working on some solutions which could be exceptionally relevant to this. I am also like doing something along those lines, but yeah, nothing on scale at this point in time. But there are a few companies who are working on this at scale, and I would recommend people to go. I'm not dropping names, of course, but I would recommend people go and look up these companies who are operating with these uh, very guided but relatively unstructured projects, which you can bring into your own classrooms, which you can, um, you know, perform with your own students and see what works, because it is a little bit of a trial and error to figure out what works in your environment. Yeah.
Yeah. So thanks a lot, Mr. Jeetesh.
Mhm.
Those are the questions I have prepared, and a couple of I have received from other speakers. Before we end the session, you want to mention anything else, sir?
No, nothing as such. Thank you for having me over here, and thank you for listening to this out there ideation as well with me.
Thank you, sir. Thank you for sharing your knowledge on our platform. Have a great day. I'll end the session now.
Thank
Thank
you.
you.
Bye bye.